Hello everyone, my name is Armin Bernstetter and I use the pronouns he, him. I'm a doctoral researcher in the Mar-Data Helmholtz School for Marine Data Science and I am employed at GeoMar Helmholtz Center for Ocean Research Kiel in Germany. The topic of my talk is a tool we are developing for visual and immersive analytics use cases at our institute. The slides for this talk are HTML slides, so you can also go through them online under this address. There's also a video embedded in which you can see a short example interaction with the tool I am presenting today. Before I go into more specific detail, let me raise you this question. How reproducible are visual analytics workflows? Imagine you have some research question, and to solve this research question you engage in a sense-making process using visual analytics. You emerge with insights and some form of static image of visualized data which you publish. But will everyone who reads your publication be able to retrace your steps? Will you yourself be able to remember how you interacted with your visualization software after a year? We argue that if the insights and a static image of the visualization are being published, so should the process. But let's take a step back. We're first going to talk about some examples of visual analytics in ocean research, then a quick recap on visualization provenance. Afterwards, I'm going to give a quick overview of the current state of our tool, which we call the Digital Lab Book. And of course, I will give a conclusion and a short outlook. Let's start with fieldwork in geology as an example. Traditional geologists' fieldwork consists of going on research field trips to quarries where you can directly interact with your studied objects. You have your geologist's hammer and your geological compass. You measure, for example, strike and dip of layers of rocks. You do this collaboratively with colleagues. You take notes, make drawings, and gather insights in a sense-making process directly on site. All of this is not possible for marine geologists researching, for example, deep-sea hydrothermal vents. You can deploy divers, submarines, remotely operated or autonomous underwater vehicles, but this would all be very costly and will still not allow you to directly interact with the environment. Therefore, even more than on land, ocean researchers need visual analytics. I'll now show you a few selected applications and use cases. Maybe you have some experience with geographic information system software. QGIS is a powerful open source program which finds a lot of use as a multi-purpose tool also in ocean research. It is desktop-based, allows a lot of interaction and is extremely extensible by a large plugin ecosystem. In this example you can see a part of the Southern American continent with bathymetry and topography data, including outlines of the exclusive economic zones in black and earthquake frequency data. An important method in ocean research is photogrammetry. Seafloor modeling can be done using photogrammetry techniques, 3D laser scanning, which allows to build advanced 3D models or point clouds, which can then be measured in programs. For example, this program you can see here is Poetry, an application developed at Technical University Vienna, which is a point cloud viewer and allows some interaction and measuring with the point clouds. What you see here is part of a deep-sea hydrothermal vent field in the Niue South volcano between Fiji and Samoa. An approach to immersive analytics for geology is VRGS. VRGS is a project implementing exactly the requirements for geologists to do virtual fieldwork. In this screenshot, you can see, for example, a measurement of the strike and dip, which you would normally do on site with your geological compass, which you have seen previously. VRGS is available usable either as desktop application or in virtual reality. And then one of our crown jewels, so to say, at GeoMar is the Arena 2, a spatially immersive visualization dome for collaborative sense-making through visual analysis. Its idea is to be a simulator for virtual geoscience fieldwork but classic planetarium software is also integrated, for example, as well as state-of-the-art Unreal Game Engine virtual production technology, which can be used to facilitate the power of modern game engine technology for visualization purposes. Nevertheless, independent of the approach or application that is used, the processes need to persist in some way. This allows better transparency, reproducibility, and publication of your visual analytics results and workflows. There is a recent study from Ziegler and Jasons published at CHI 2023, where they discover, among other findings, an urgent need for more provenance in GIS systems. Therefore, let's dive into a short recap on what provenance is about. The World Wide Web Consortium defines provenance as the sources of information involved in producing an artifact, and that this information can be used to assess the artifact's quality, reliability, or trustworthiness. This mentions the issue of quality assessment. For this, let's take another quick step back and take a look at how to possibly assess the value of a visualization. In 2005, Van Wyk proposed a model on how to assert and quantify the value of a visualization. The model considers the costs of creating a visualization and the costs of making sense of it. These costs are then compared to the gained insight and increase in knowledge. But you need to somehow be able to prove that the visualization gives insight. And this is where provenance information comes into play. Doe et al., for example, extend Van Wyk's model by proposing ways how to capture a user's reasoning process in visual analysis workflows. With this information, you then have proof, or at least arguments, for the value of your visualization. And these reasoning processes, together with the state history of the visualization application, are what we in this case understand as provenance. And for this purpose, we are developing the Digital Lab Book, a provenance management tool. The two main tasks that form the basis of the Digital Lab Book were how to support fieldwork if you cannot get to the field. Remember the notebook drawing on the geological fieldwork slide. And the lack of provenance in geoscientific visual analysis processes. The Digital Lab Book is a tool acting as third party to a given visualization application. It captures visualization states and user-defined time steps and enables returning to previous states, branching, and therefore also the exploration of what-if scenarios in your analysis workflow. It supports taking notes and creating mind maps, which means explicit externalization of reasoning and thought processes. It also allows to export and serialize the gathered artifacts of visual analysis provenance, which can then be published. It is, however, not just an elaborate undo-redo button and history management software, and it does not track low-level events and interactions such as mouse clicks, but rather distinct states. We chose to develop the Digital Lab Book as a web-based application to keep the possibility of potentially offering its functionality as a software as a service. The front end is written in Angular and the back end is a simple Python Flask architecture. For the provenance management and as a sort of database, we use Python bindings to libgit2, since Git versioning offers already much that we desire from such a tool. And this also allows easy sharing and therefore publication, for example, by submitting the Git repository folder as supplement or by uploading the repository to GitHub or GitLab to be accessed by everyone. Of course, the Digital Lab Book can't simply connect to any and all visualization applications. The currently supported applications all had to be slightly modified in some way. But in general, the minimum requirements for an application to be supported are a sort of API that allows to save the current state of the application and visualization as a file and load such a file again during runtime to return to the exact state as before. In the best case, this is a file that can be version controlled and for which a file diff can be calculated. Currently, the Digital Lab Book is able to support 4 different applications. The Digital Earth Viewer, which is a web-based visualization application developed at Geomar, Poetry, which is a point cloud viewer that I have seen previously, QGIS, and applications built in the Unreal game engine. Now let's take a look at the Digital Lab Book interface. The dashboard is the landing page, so to say, and leads a user through a multi-step process with skippable steps to set up the repository and connection to the visualization application. It also allows to export and import a packaged Provenance archive, which in simple terms is a Git repository containing all visualization states, thumbnails and screenshots, and metadata for the repository. The history view combines a provenance or history graph, which you can see on the left, with a scrollable list of the scrollable list view of the latest n states of the currently checked out branch, which you can see in the bottom right. There's also a replay feature which is able to send back a sequence of states to the visualization application, which you can see on the right side in the middle. Clicking on a thumbnail of the scene opens a pop-up window of the state with more detailed information. You can return to a state, create a branch from that state, add a node, or add the state to the mind map using these buttons. The mind map is a currently rather simple mind map implementation for knowledge organization and includes basic features like creating and linking nodes, creating clusters from multiple nodes, color picking, etc. Now I'm giving you a quick outlook and concluding this talk. Obviously, there is always something more to do. The most important points for the Digital Lab Book now are to actually support immersive analytics workflows and track provenance artifacts that arise there. For example, in the Arena 2. We have an OptiTrack setup in the Arena 2, which would allow to record motion tracking, but other possibilities are to record eye movement or eye tracking, or also things like speech to text. Then what's also important from a research standpoint is the evaluation of this tool. We plan to do this by focusing both on a selection of in-depth use cases of domain experts in a qualitative evaluation, but also with a quantitative evaluation in user studies with both domain scientists and non-specialists, for example, university students. To conclude, the Digital Lab Book is a provenance capturing and management tool with the original goal of supporting visual analysis use cases at our Ocean Research Institute. I'd be happy to talk to you about your experience with visual analysis provenance or immersive analytics, or if you have any other input to this project. Thank you.